Hi everybody and welcome to Thursday, March 19th. Today I'm not going to give you new information. I'm going to give you a review of the three kinds of systems we have and how we graph each one and what decision we'd make. There's also going to be no additional homework tonight. All I'd like you to do is finish the two IXL tasks, U.2 and U.4, to at least 90%. Those are due tomorrow. So, on the board, I have an example of one type of system, and as usual, you're going to have to make sure they're both in graphable format. This one is already in slope-intercept form and is good to go, but this one's in standard. So, to put it in slope-intercept, I'm going to subtract 2x from both sides. I get 4y equals negative 2x plus 8. Then I'm going to divide everything by 4. And I have y equals negative, 2 over 4 is just 1/2. X plus 8 divided by 4 is 2. At this point, both of the lines are in slope-intercept form, and I can graph them. Well, I stopped by school today for possibly the last time, and I picked up some graph paper. So I'll use that for this example. It's easier if you can actually see the graph. So here's what I'm going to have, all right, I'm going to hide my markers apparently. I'm going to make a coordinate grid that will go up to at least positive 5. All right, so here's a grid, and I don't know if you can see the grid lines, but I'll put them here. 1, 2, 3, 4, 5. I'll also put some on the x-axis. And let's see what's going to happen. This one has a y-intercept at positive 2, so I'll put a dot at positive 2. And the slope is negative 1/2, which means it's going to go down 1 and over 2. And you can do it again if you'd like. So this is this line right here. My other line has a y-intercept of 5, 1, 2, 3, 4, 5, and it has a slope of, 1, it's 1x. I can't really go up and over because I ran out of room, so I'm going to do what we did before. When I can't go up and over, I will go down and to the left. So here and also there, and what I can see is that it's crossing right over here. Looks like it's negative 2 and positive 3. Now, negative 2, positive 3 looks to be the solution. For strand U.2, that's where you would end. You would say that the solution is 2, negative 3. We can also, of course, check it by plugging in the values and seeing if it works in both equations. It has to. So let's do that. All right, real quick. If that's my x and that's my y, they should plug in and work no problem. I'll do this one first. It's easy. 3 equals negative 2 plus 5. Well, negative 2 plus 5 is 3. That works out no problem. This one over here, if y is 3, it has to equal negative 1/2 times x, which is negative 2, plus 2. Well, that means 3 equals negative 1/2 times negative 2 is positive 1. And obviously, 3 is 1 plus 2. We have a solution and we're happy with it. All right? So again, for U.2, you would solve the problem, and that would be the solution, the coordinate negative 2, 3. For U.4, it's asking how many solutions will there be? Well, in this example, there's one solution. It's the coordinate negative 2, 3. All right. Well, that will work for most of our questions. However, there were also the two special systems. So let's look at special systems. Well, my first special system that I'll talk about right now is the one in which you have the same line, which would be infinite solutions. But let's just see the example. So here's my example. I have 5x plus 10y equals 20, and I have x plus 2y equals 4. All right. Again, I have to put them in graphable form. They're both in standard this time. Subtract 5x, 10y equals negative 5x plus 20. Divide everything by 10, and y equals negative 5 over 10 is 1/2. X plus 20 over 10 is 2. Seems that I like the slope negative 1/2. Just happens to be the way it is today. This other equation, again, subtract the x from both sides. We have 2y equals negative x plus 4. Divide everything by 2. Y equals negative 1/2 x plus 2. At this point, I would hope you can see they're the same line. All right, well, let's just say you can't see it. You don't recognize it. Okay. Positive 2 is my y-intercept. The slope is negative 1/2. It goes down 1 over 2. So here is line number 1. But the other line happens to be the exact same line. So it's got a y-intercept at positive 2, and it's got a slope of down 1 over 2. And when I graph it, I get the exact same line. Hey, look at that. We have orange and black. Welcome back to Shelton High. That's the same line graphed on top of itself. If this were u dot 2, you'd say they graph on top of each other. It would be graphing to solve. When they're the same line, there are infinite solutions. The reason, again, is a solution is the place where the two lines cross. These two lines cross everywhere. You could also use the infinity symbol to indicate that. Okay, well, our last example would be the one in which the two lines don't ever cross because they're parallel. You already should know parallel lines when you see them because you have the same slope but different y-intercepts. But again, let's just pretend you don't recognize it. Okay, two lines are negative 2x plus y equals 1, and y equals 2x plus 4. Well, I'm going to add 2x to both sides. Y equals 2x plus 1. That's good. That's already in slope-intercept form. Now, with this example, again, just like the previous example where they had the same equation, you could probably see that these two equations have the same slope, positive 2, but different y-intercepts, 1 and 4. They're not going to cross. But if you can't see that, or you're just not quite sure, or you have to graph it, let's take a look at the graph. All right, I'll put this one over here. So if I have my coordinate grid right there, and I'll just identify some marks in case you can't see them, but they are here on the graph paper. Going to graph my two lines without too much stress. The first one has a y-intercept of 1 and a slope of 2, so up 2 over 1. And if you want to do it again, it's right there. Here is my first line. The second line has a y-intercept of 4, so it's up here at 1, 2, 3, 4. It's got a positive 2 slope. I can't go up because my paper ran out, so I'm going to go down to the left one. And what do you notice? Oh, those two lines don't cross, which we already kind of knew going into it. Well, what happens when two lines don't cross? We would say they have no solutions. There's no points of intersection of either line. So this solution, you'd say, has 0 solutions. Okay, 0 solutions. So the S fell off. The reason for it, again, they're parallel lines, and parallel systems have no point of intersection. I hope that was helpful to you guys. Please get the IXL done, U.2 and U.4, for tomorrow by the end of the day. Starting on Monday, we have to institute our attendance policy. All that means is I'm going to post a document along with this link, and you'll just find your name and check it off, or enter your name, however I decide to do it. Just make sure you actually see the videos before, let's say, 5 o'clock in the evening, all right? That's plenty of time for you to sign in. That way I can enter the attendance and not worry about whether you guys are actually doing the work. The school wants to know that you're paying attention. I do too. I hope that was helpful. I'll see you soon.